Yeah, here we have section 2.8, proving angle relationships. So our main ideas and vocab, no new vocab this time. So a couple of postulates. So the first one's a protractor one, in which you measure an angle with a protractor, and then you have the angle addition postulate, which is similar to segment addition. If you have two smaller angles and you add them up, you get the full angle, or it lets you know which points in between the two. So example 1. So we've got the flag here shown below. So ABD is 44. It tells you also that ABC is 88. And how much is DBC? Well, if the full thing is 88, you can subtract off the part you know to get the part that you don't. So measure angle DBC is equal to 44. So a couple more theorems here. You've got the supplement theorem, which two angles form a linear pair, then they're supplementary. A complement theorem, if two non-common side forms a right angle, then the angles are complementary. So here, example 2, if 1 and 2 form a linear pair and 2 is 67, find 1. Well, if they form a linear pair, 1 plus 2 has to be 180. And if angle 2 is 67, subtract the 67 from both sides, giving you 113. And there's your answer. Alright, so these are just the reflexive, symmetric, and transitives for angles. Same thing for segments. These two down here. So the first one, angles supplementary to the same angle or two congruent angles are congruent. Angles complementary to the same angle or two congruent angles are congruent. Okay, so example 3 here, so it says 1 and 2 form a linear pair, 2 and 3 form a linear pair, prove that 1 and 3 are congruent. So measure angle 1 plus measure angle 2 equals 180. You also know that measure 2 plus measure angle 3 equals 180. Now since they're equal to each other, so these things are both given, since they are equal to each other, since they're equal to 180, I can say they're equal to each other. That's by substitution. And if that's the case, measure angle 1 equals measure angle 3. That's subtraction. I subtract out the angle 2 from both sides. And to prove them congruent, that's just the definition of congruent. Two angles that are equal are also by definition congruent. So 2.8 here, if two angles are vertical angles, then they are congruent, which is actually what we just proved right there. And example 4, if 1 and 2 are vertical angles, and 1 is x and 2 is that, find 1 and 2. Well, if they're vertical, they are equal to each other. So if I bring the 3x over, I have 4x equals 228, which means x is 57 degrees. So that's measure angle 1. Because measure angle 1 is x. So measure angle 2 is going to be 123, because it has to add up to, nope, I lied. They're vertical, which means they are equal to each other. You don't actually have to do a substitution step. You could plug your x back in here, 228 minus 3 times 57, but you'll get 57 back out. Because since they're vertical, they have to be equal. And here we have some rules for lines that are right angles. So perpendicular lines form 4 right angles. All right angles are congruent to each other because they're all 90. Perpendicular lines form congruent adjacent angles because they're right angles. If two angles are congruent and supplementary, then each one has to be a right angle because they have to add up to 180 and they have to be equal to each other. The only way to do that is make them both 90. If two congruent angles form a linear pair, then they are right angles. Once again, similar thing to here. Alright, that's the end of the section.